2 and 1. Here's an interesting example that relates to compound interest and paying off a loan. So notice it says that Bella has a loan for $2,000 taken out today. So I'm going to draw this out here and just show you what's happening. So you have a loan right there. Now that particular loan is supposed to be repaid by a payment of $1,200 in 6 months, and then a final payment of $1,000 at an unknown date. So we don't know what the date is of that $1,000 second payment. What we do know, is that this one is going to be, okay, right there. But the other one, we have no idea when the $1,000 is supposed to be. And that's what we're going to be trying to find. Now, interest is 12% compounded monthly. So we have a compounding of monthly. And then it says, when should that final payment be made? So now we don't know when it is. We have no idea if it's going to be here, so past the 6 months, if it's before the 6 months, or even further. So we have no idea where it's going to be. So let's try to find it out. Now, how would we find it out? Well, remember that we need to, this is kind of equivalent values type of question. So we have a loan of $2,000. So we know that. And that is supposed to be equivalent to the money or the payments that we're going to be making. Now, there's 2 payments there. So we need a focal date, right? We need to be able to compare the loan and the payments at exactly the same time. Now, in this case, it's probably convenient to compare the money today. All right, so I'm going to be bringing money back. So I know I'm going to be bringing this money back. And I'm going to have to bring this unknown back as well. But I do not know, okay, what that exactly is and what does it entail. So let's call this number 1, and then let's call this number 2. So I know that 1 plus 2, if I knew the date, they would be equal to $2,000. All right. So now I will do the first calculation because I know what this is exactly, right? I can find out exactly what this is. I can then move it to the other side, and then I can check how much of the loan do I still have to repay. So let's do that first. Okay, so number 1 that I'm going to work with is, so since I'm bringing money back, so present value equals future value 1 plus I. So this is my discounting factor here. And let's take a look what that would be. So my future value is 1,200. My 1 plus, now my I, so notice I have written it right here because it's 12% compounded monthly. So monthly, that actually works out nicely there. And then my N, well, I am at 6 months. And because I am compounding monthly, so it's basically 6 terms. So this is going to be a 6 here. So I can find out what this is. So let's do that. And you can do that in any way. You can take out your business analyst if you want. All right, so I have that raised to the power. Now let's not forget that it's going to be negative. So if I raise that to that power and round it to the penny, so I'm going to get this. Now notice it is less than 1,200, and it should be because we're bringing money back. Now what does this give me? Well, what this gives me is the following. So now I know that I have $2,000 that I need to repay. That number 1, so this one is 1130.45. That's my first payment. That's the equivalent value today of the $1,200 in 6 months, right? And then I still have plus 2 right here, which I have no idea what that is. So bringing this over to this side, so it's going to subtract. So what I'm going to have is $2,000 minus 1130.45. Okay, and we're going to see what that gives us. So this is going to be $869.55 that I still have to pay off from the loan. So let me make that red. Okay, so just so that you know that I'm still needing to pay this off. And now that is supposed to be equal to number 2, which is this $1,000, but I do not know when that date is, right? So bringing that $1,000 back, it's supposed to be that $869. Okay, all right, so this is going to be the present value, right? So this is really the present value, which is going to be equal to the future value, all right? So it's going to be equal to the future value, 1 plus I, all right? And then I have no idea when this is happening. So notice that in this question, actually, you know what the present value is. It is the amount that you still have to pay off. You know what the future value is because that's $1,000. You know what I is. I is 12% compounded monthly, which is 0.12 divided by 12. So the only thing that you don't know is N. That's the only thing that you don't know. And this means that I can use the formula for N, or I can use my business analyst calculator. So I'm going to say N equals, because the formula in this particular case is going to be, so what do I have? So now notice this is the future value, present value. It's going to be ln of the future value divided by the present value divided by ln of 1 plus I. So that just comes from the formula, okay, that we have. Now, substituting everything in, it's going to tell me what that N actually is. So within here, so if I'm going to solve this out, so I can substitute everything back in. So let's check what N, and N is the number of months. So this is ln. So future value was $1,000 divided by the present value, which is $869.55. Then divide all of that by ln, and this is 1 plus 0.01. And I'm going to just hit equals. And notice, so this is, okay, so it's approximately 14 months. Now, what does this tell us? It says that that second payment, so this second payment, I guess, okay, so this basically, it means it was a little bit further out. Okay, it was at approximately 14 months off. So your loan of $2,000 is going to get paid off by $1,200 at 6 months, and that $1,000 would have to be at 14 months. And that's how you would do this particular example. This is a fantastic example. It's not an easy one because it combines equivalent values with finding the compounding number of terms N that you would have. All right. Okay, so thank you for watching. Okay, I hope this was helpful. Bye, everybody.